All right. So Candy, I'm recording this. I hope that it helps you if you can't make it in today. So if we look at the standard normal distribution, okay, all this is, if you take all the data, remember when we did the dot plots, which were, you know, we've got, you know, just data points listed. One way we can look and see what the mode is by simply looking at that dot plot. Okay? All this is a dot plot with a huge database. So what that says is that at this point right here at the top, that has the most values. It's the mean. It's also the mode of that data set. Okay? So again, I emphasize that these things apply to big databases. If you've got a small set of data, maybe only 100 points of data, you may find that it looks like this. Or this. Or even that might look like a dromedary, a camel. But that's a small database. So in reality, the z-score, remember a z-score, z is the value of any one data point, we'll call it x, divided by the standard deviation. Okay. And remember, the standard deviation depends on how widespread, how spread out the database is. If it's compact, the standard deviation is going to be small. If it is broad, which in many very large databases you would expect it to be broad, but not necessarily. I mean, if you just look at the distribution of ages in the society, right, it's going to go from 0 to 100 plus, with very few people being out at the 100 plus end. So we know that that's the range we're dealing with, basically 105 maybe. So, but if you look at salaries, they're going to vary from very small to millions of dollars a year for the outliers, the CEOs, right? So again, much broader range, much larger standard deviation.
So the z-score helps us.
Helps you, yeah. The z-score basically gives you, okay, let's relate this back. The z-score is actually a way of calculating the probability of the next data point that you acquire for that data set falling at some point in this. Okay, so if we look at this, we've got, I want to do this right now. So we've got s equals 1 or minus 1, and we've got s equals 1, and we've got s equals 2, and s equals minus 2. That's the standard deviation. Remember, there is a 95% probability of any randomly chosen data point out of the data set falling between -2 standard deviations and +2 standard deviations. The z-score can be related to a table, that normal distribution table that I gave you on Monday. That actually is the probability of the next data point falling at that z-score. If you read off the table, it's basically a probability table. Now, what is the value of that? Well, the value of that is when we have to do a lot of statistical analysis. I doubt seriously that's going to be a big part of your job, but understanding that we can use z-scores to actually compare data sets. Because when we do that, x divided by s, we basically normalized this to that standard table where the mean is 0 and the standard deviation is 1. Okay, so all we've done is standardize this so that we can use that normalization table to read the probability. So this is part of predictive statistics, and it's part of various forms of technical testing that statisticians do. So
who normally uses this?
Pardon?
Who normally puts this information in?
Professional statisticians that are using the statistics, there are two kinds of statistics. Mostly we've gone through descriptive statistics here, which is calculating the standard deviations and the correlation coefficients and all these things, these calculations that we do. And then there is inferential statistics, which is taking that information and making predictions and drawing conclusions. This is in the political polling that we see, goes out and collects all that raw data, does their analyses, does the standard deviations, all the other things that they do, and then comes back and scales that up. Inferential statistics allow us to take that sample and scale it to the population. That's why we see something like, 53% of the population supports candidate X with an error margin of, say, 2%. And the way they calculate the error margins really depends on their method of collecting the data. What that also says is that when you have a sample, you can't immediately take it to the population, because that 53% is an inference for what the population, in this case, people who actually vote. And part of the problem with political statistics like that is that they go out and survey likely voters. I mean, they can't go out and survey voters because they haven't voted yet. So they survey likely voters. If you ever get involved in a political survey, one of the questions will be, are you going to vote in the next election? If not, that's the end. What you think is irrelevant if you don't plan to vote. So they go out and they do these likely voters. Well, a likely voter is not a voter. So there's a probability that they won't vote. So that's where those error bars come in. Is okay, but we know that some of these aren't going to vote one way or the other. So what you want to keep in mind is that these things are not saying that candidate X is going to get 53% of the vote. What they're saying is that it looks like 53% of the people that might vote in this survey have said that, but if your survey does not include sufficient variation in the country. I mean, it's one thing to do a survey of people voting in, say, our U.S. congressional district. Okay? We can have a pretty good feel for what that might be, because we're largely a single group of people with some of the same concerns, the same economic conditions, all those things. I mean, with a lot of variation that goes from CEOs to unemployed. But you know what I'm saying here. If we go out and try to scale that up and say, oh, well, because this particular congressional district is going to, probably going to elect a representative from this party, we can't scale that up anywhere else. We can't say anything about the rest of the nation. And the problem with all the political polls is that if they don't sample a lot of the country, then those, I don't pay attention to them for that reason. And because I don't pay attention to them partly for that reason, the rest of it is I don't know what questions they've asked. As we know from our first week, you can really skew your results with your questions. So, so these kinds of things allow us now to make calculations. And the Z-score merely gives us an idea to be able to predict what the likelihood of the next data point being someone we want, something we're after. Because that is, these are all probabilities. Note that every number in the body of that table, not the columns and not the sides, the column headings and the row headings. Every number there is less than 1. Okay. Because there is no place that has a 100% probability. And so that these tables allow us then to say, if we go out now and choose another person, what's the likelihood it's going to be? The answer to this question is going to be whatever you're looking for, and that's how we can use these. What it also says is that the bigger the database, the more accurate our results if we're trying to do inferential statistics. But as I told Crystal earlier, before you got here, if you look at a probability, you can also look at the probability against, and either one can happen. And in fact, randomly choosing, everyone each is going to happen. Even the most unlikely events can occur. It's possible, but unlikely enough that you'd never, make a large bet on it. It's possible you could go up to Blackhawk and play craps and roll 7, that's the winning if you roll it on your first roll. Roll a 7 10 times in a row. Is it likely? No. Very unlikely. And that's what the casinos look at. They're looking at people who roll that first 7 and then they lose it the next time around.
Because they're like, I'm going to roll it again.
All right. Turns out that 7 is the most likely result of rolling 2 die. You have a 1 in 6 chance, it turns out, of rolling a 7. Everything else is lower. Which is why when you roll anything but a 7 the first time, if you roll a 7, you lose. You crap out. Because they know that the chances are, if you roll, say, a 4 the first time around, the chances are much greater that you'll roll a 7 before you roll another 4. So, which means that craps is not, at least for that purpose, there's lots of choices on a craps table that are much more likely to give you a win. Your win is much smaller, but a win is a win, right? More money on the table after the roll is always a win, even if it's just a few cents. So anyway, but they depend on that. And so there again, that's using statistics, understanding the statistical likelihood and taking emotion out of the gambling. You know. And people like me who just look at it and say, well, it's throwing our money away. Well, it is definitely. But we have some friends who live in Lewiston, Idaho. And Lewiston has a casino. And they go to the casino. Well, he likes to play poker. And if you are a good poker player, you can win because most people are bad poker players, you know, quite literally. But she has figured out a system to where she can win at the slot machines. Now, she was a finance person and a banker, so she's very, very astute with money and with numbers. And so she has figured out a system, watching other people play. She knows what machines are most likely to pay out next, and she goes there. She used to take her winnings. She'd win all the time. And they would always invite them back because they want to get that money back. Mm-hmm. But also, having other people watch her win encourages them to play. Since they don't understand the system, they always lose. So they make money no matter what. So what if she walks out? She would go home and throw her winnings up on top of a cabinet in her kitchen, I think. But she just throw it up there. And one day she decided, well, what would I've got? $12,000 sitting up there. So they enclosed the porch on the back of their house with her winnings and turned it into a wonderful room to watch the birds and the deer and the wildlife out in the back of their property.
David and I always get mad at when we go to Central City because I'll do good and I'll start to get the money and then I'll start to lose it a little bit, so I'll cash out and I'll go on and find a different one. And I start to do good and I'll start hitting money and I'll cash out. Yeah. So, well, you gotta stay there, it's gonna hit big. No. I just put $20 in here. I have $800. I'm walking away.
Yeah, that's a nice return on $20. Yeah, that's why the casinos give you rolls of nickels or quarters or whatever they're giving you these days, you know, to encourage you, or a small stack, right? I don't know what they do these days. Used to be.
They give you like a card, like a debit card.
Oh yeah, they used to give us rolls of nickels. Yeah. Yeah, I want to feel the money. Yeah. But yeah, they used to give out rolls of nickels, you know, and they figured, well, you'll spend your $2 roll of nickels, right, and then you'll start pulling money out of your wallet. So, but not being a gambler, I don't get into that. I used to play penny ante poker with friends, but it was an excuse to laugh and drink beer. I mean, literally. Nobody ever walked out with more than a few dollars extra. And everybody sort of came out even in the long run. So it was just for fun. It was just the guys getting together and laughing. But, you know, people who really go, who are addicted to gambling for whatever reason, exactly that. Oh, if I keep going, I'm going to hit it big. And all of a sudden, everything is flushed down. They've got your $20 you started with. And, you know, they're happy. I mean, they've got more money than they started with. And again, they see people who see others winning are going to play more. And if you can be disciplined about it, you can make money in the casinos, but you have to be disciplined.
I like to suck them in on poker too.
Pardon?
I like to suck them in on poker too. You'll go up there in a tournament and there'll only be like 2 or 3 women. And they pick on the women. They do. They're like, oh, well, you know, she's going to be a sucker. Let me get her out.
Yeah.
I got third once and I got second. I don't know, but we did pretty good that day. Yeah.
Again, if you really are disciplined and play the odds, you know, there's a skill to it, the bluffing and stuff. I don't know if you saw the movie Crazy Rich Asians.
Not yet.
It's kind of fun. And it's absolutely full of these rich, gorgeous people, right? But the first scene is the female lead, Constance Wu, playing a character who teaches economics at NYU. And she outdoes a poker champion in her class. And of course, it's all for show, but nonetheless, I mean, but that's what it is. She basically bluffed him. And at the end, there's another scene where she does something similar.
We should do that in a nice class.
Yeah. But the issue with these things, and again, let's go back to the question about what's the use of z-scores, and it's really for predictive sorts of things. We can calculate from this. I mean, if we've got a point on this line, remember this line is just the number of data points at that value. That's all that is. That's what a normal distribution is. Any one point on the curve itself is reflective of the number of data points that returned that value. And in a large enough population, virtually everything is going to be normal in its distribution. So we can use that to calculate those probabilities. Now, when we're not talking about a sample, and we do that, we can do this with a sample as well. We calculate the z-score by simply the value divided by the standard distribution gives us a z-score. We look on the table there, and we have a probability, a number less than 1. Right? That's the probability of a randomly chosen point appearing at that position on the curve. That's all it is. And this is useful when, again, we're trying to do, this is numerical data. Obviously, when we are looking at doing what we call logical data and voter surveys and stuff, and surveys like the satisfaction score. That's just a representation of how satisfied someone is on that particular one. So but logical data are a little different in their analysis, but essentially they put a numerical value on these things and use them as a way to classify the data. It's different kinds of statistics. But we've got down on question 4 on week 3, we've got these yes, no about the enough time for lunch. Here is where we start playing with establishing these statistical results, so that we can say that girls and boys, girls look like they have about a 40% chance of saying yes. Okay, actually not. It's about a 30% chance of saying yes, that they have enough time at lunch. So you would then say, okay, there's a 30% chance that the next girl we randomly ask that has not participated so far is going to say yes. Note that there is then a 70% chance she will say no.
So the line, like in question A, the line over the lowercase b,
Mm-hmm.
what is that?
That's the complement.
The complement. Okay.
Right. Remember, the complement, if something has a 30% chance of happening, its complement is the 70%. Okay. So that's the complement. So all it is saying, instead of saying all it is saying that, again, if all other things being equal, if you just surveyed another student without knowing ahead of time that it was going to be a girl or a boy, that would be the probability of getting a boy. Okay, or the probability of selecting a response that wasn't from a boy. That's what the complement is. And we have to think about the complement. Compliments are funny, and the questions are funny. We can ask questions like, what if we randomly chose a response, what would be the likelihood that it would be a girl saying no? Right? So we can calculate that. We have 110 no's from girls out of 300 total responses. So we can calculate that. So it's about 1/3, about 33%.
Oh, I was doing that wrong. I was trying to do 42 and 110. I'm like, and it kept telling me that my probability was too short.
Right.
Okay.
So, right. So what we want to look at here is we have to ask the question, and then we have to define how we're going to answer it. If we're looking at what is the probability of the response being no from a girl, if we just randomly chose one, that means we've got the entire population, boys and girls. That's our base, our 300. Okay, and then there's 110 of those responses, no responses, came from girls. So that's a different question than picking a random thing and saying, what is the probability that the answer was no? Then we'd be looking at the total of no's, 163 out of 300. Okay, yeah, you have an appointment. We'll see you in a bit.
Okay.
So there's, again, we have to read the question carefully and then ask ourselves, what is the population? I mean, there are 300 students. That's our population in this study. It may be a sample, and it probably is only a sample at a K-6 grade school. But nonetheless, the population of the study is 300 people. Of those, there were 152 girls and 148 boys. Well, it turns out that that's probably a pretty good random sampling, because there are usually a few more girls than boys in a large population. Probably not a difference of 5. But nonetheless, we'd expect to have more girls in a large enough population, because statistically there are more women, more females. So we are looking at these as a question of what's our question? What's our population? Okay. And again, what is the probability that the answer will be yes? Well, now we're talking again, if we don't include the 2, as in a gender and a yes, then all we're doing is looking at 300 responses, and 138 of them have been, or 137 are yes. Okay. But if randomly choosing, what if it's a boy saying no? Well, we've got only 53. Okay. And given that the responder is a girl, what's the chance of yes? Well, now we put a restriction on it. And now we have reduced that to 152 responses from girls. So we've got a 42 out of 152 probability of getting a yes given that we started with looking at a girl. Okay, does that make sense?
Yeah.
So we can put restrictions on these things, and they can get really tight. I mean, this is a fairly simple one. We've got 2 genders and 2 answers, right? So we have a grid of 4 sets of responses. But we can we can look at a lot of things here. We can look at this and say, okay, it appears that more girls than boys say there is not enough time for lunch. Okay? Because we've got 42 out of 152 versus, saying yes, versus 95 out of 148 of the guys. So the guys are more satisfied with the amount of time at lunch. This does not say anything about why. It would prompt us to say, why do the girls think they need more time at lunch? And there can be lots of social reasons for that. Or there can be other factors to throw in as well. But if all we're doing is doing this and saying that, you know, the girls want more time for lunch and the boys are less inclined to want more time for lunch.
And I don't know what like year this was done.
Yeah.
My mother would go home for lunch. So depending how far away.
Mm-hmm. Yep. Yeah. I lived when I was at my last grade school. I lived basically a block from school, so I went home for lunch every day. When the school I was in before we moved to Arizona, and I went to that one, it was about a 6 or 8 block walk. And at that time, it was perfectly safe to walk 6 or 8 blocks through the city of Richmond with me and my sisters, just the 3 of us. But we couldn't go home for lunch. There wasn't enough time. So we'd have to carry our lunches. So, you know, again, it depends on that. Yeah, and a lot of cases. But yeah, there was a time when most people went home for lunch because they were in neighborhood schools. Getting up to high school, because you drew in from a larger area, that was different. But again, looking at that and asking that question. When I was in high school, as a senior, we could go off campus for lunch. So they had all sorts of restrictions there. So, but anyway, does that make sense? Okay. The rest of them should be straightforward, I think, at least there. 7 and 10 factorial ought to be easy. The permutations and combinations, we talked about those. I'm not terribly worried. Those don't appear on your final. If you can do them, fine, but it's an understanding that of really how many different ways things can be arranged given restrictions. With the permutations, remember, there is, if you're looking at the ways you can arrange the letters A, B, and C, well, A, B, C, and A, C, B are different, and so those are different. In a combination, we're talking about if we looked at the alphabet and did 3-letter combinations, how many of those could be done, but a combination says that ABC and ACB are the same combination because they are the letters A, B, and C. Doesn't matter the order. Okay, so that's 2 different things. And in reality, if we're looking at things like license plates, the order doesn't matter because KKA is different from AKK or KAK, right? Now, it's a little more complicated when we are replacing the number. So we have, if we look at being able to duplicate, when most of the examples you saw we are not replacing, we cannot duplicate things in that same combination. But in license plates, we can. We go from AAA to ZZZ. So what we have is if we're always replacing the letter, instead of having 26 times 25 times 24, we have 26 times 26 times 26. And in reality, we have 26 factorial times 26 factorial times 26 factorial as that. And then that's going to be divided because we only have 3 choices. So we're going to have a different denominator, and that's more complicated. We haven't gone into that because it becomes a little more difficult to calculate. But the issue is that we have a chance to look at these as permutations and or combinations. But in every case here, we are saying that we cannot, once you take something out of the available pool, it's not there anymore, which is why we use the factorials. The implication on question 7 for 1 to 9, you choose 4, is that, again, we don't have the ability to duplicate the numbers. So we can't have 1, 1, 1, 1 or 5, 5, 5, 5. Okay, that's an implication there. Can we do that? Absolutely. A 4-digit code is a 4-digit code. So we've got 10 factorial times 10 factorial times 10 factorial times 10 factorial. In other words, lots of different potentials. But since we're only a 4-digit code, we have to somehow reduce that. So in reality, it would be, we'd have to look at a much more complex formula, and there are formulas for that. But we haven't gone into that because we didn't have time to play with that particular. It's an interesting problem, and I wish we would have if we hadn't lost basically 2 days of class this month. I would have loved to have gone into the more practical. I mean, that is a practical issue. I mean, doing these kinds of things is, these kinds of calculations can be a very practical part of someone's business. And a lot of it's used for these kinds of calculations are used for evaluating claims of evaluating our sampling methods for QA. That if we are claiming an error rate of say 1 in 1,000 in computers, in computer manufacture, and a dud machine rate, if you will, then this allows us to go through and calculate the likelihood of taking a sample it helps us the likelihood of taking just a sample out of a manufacturing run. What's the likelihood of us finding a machine that is defective? Okay, and that then allows us to actually choose the QA sample size that we're going to take to actually determine whether or not our error rate, our defect rate is low enough. And if we want, the lower the defective rate, the more samples we have to take to back that up.
And that's quality control.
That's part of quality control. So it helps us calculate what we have to do to be able to make a claim. And there's a question that in one of the, in the text here, that basically says, a company says that there is a 1% defect rate. And then what is the likelihood that that claim is correct if X number of computers are brought back to the store for repair because they don't work, and it turns out that the claim was false. So we can use that for looking at that sort of thing, and I can't remember the exact wording of the question right now. But I mean, basically, we use this as a means of if our manufacturing defect rate is set to be X, then what do we have as, what's the real rate, and how much do we have to test to prove it? And if it's not that rate, what do we have to do to our manufacturing process? So it goes back to, to our planning process, our strategic management, our process control tells us where we have to fix and change a manufacturing process, or when things are just going wrong for some reason. So anyway, it's time to take a break. It's past that time. So let's take a break while Crystal's gone. Okay. She had an appointment she had to take close by, fortunately, so she'll be back. So, and I'm going to have to, I'm going to pause, resume recording. When you're doing the intercept here, go ahead and plug the data in. You can, the way I did it, I just copied off the test, copied the data, plugged and just put it here, and then constructed a table using that. So it's pretty quick if you do it that way. So if we do that, the intercept, so we go down here to, where is it? Intercept. Just make sure you use the right column to put the data in, and it'll return it without a problem. And you can figure the slope. Okay. I did figure out how to use trend. Okay. And here is what I did. If we put in, if we use when we do the trend analysis, when we put the data in, we need to be sure that we're going down and looking at the corresponding X, but that the entire data set just goes to the end. And so I used the dollar, the keeping the range that we're working in. Now this introduces some errors in here at the end, but this first part of it is very clearly a straight line. There's a double here, which is kind of interesting, that actually comes from the fact that we have two values of 25 with different values, two values of Y with different values of X. So we end up with some funky looking numbers. So but
the trend is for each X and Y.
Yeah. So you need,
not like the whole group.
Right.
Okay.
So yeah, that's what I finally figured out. So you can use that, and then it just plots these points in. But toward the end, when we have fewer and fewer points to include in the analysis, it gets a little funky. Okay. But this straight line is right on what we calculated for the X-intercept in class the other day. Mm-hmm. And so quite clearly, it's going to go down here to the proper Y-intercept, which is minus 6.65. So
can you walk me through the trend?
Sure. So let's look at that. Let's see. If we, let's do the calculation over here. Okay. So when we do the statistical stuff, get over here to trend, and we want to have our known y's, and then insert a $ there to fix the end of the range, so that as it goes down the range of X, it only is analyzing from there to the, that's the only way I can figure it.
Where
To do it.
the one instead of 17 would be, I mean, dollar sign?
The $ merely says that every time it goes down, when it's actually doing the trend and looking at the range all the way to the bottom, it will return, it will actually calculate for what's left as opposed to what's previous. And I'm trying to,
So for
wait a minute, maybe let's try this. We want to calculate Y's. So we want the range always to be B3 through B17. And then the X's, oops, are going to be there. So let's see what happens now. Nope, didn't like it. See, that was my problem. This I don't understand. What's this coming from? All right, let's get rid of this and try it again. And in fact, we'll do it over here. Okay, so the known y's, whoops, wrong range. And the known x's. All right. So this didn't work when we did this before, right? We click on this and we get only one value. So let's try a little different. Trend B, $ B3 or B $17, which says that no matter what we do, we always have this range no matter where we are. Okay, we're going to enter that so we get that value. So let's copy this now and run it down and see what we get. They didn't like it. Okay, good enough. Get rid of that. Escape from there and go back to this function where we only did that. Okay, so now it returns the same starting value. So we want to copy this. And they don't like the reference. And that's probably because I moved it. All right. Anyway, that's how I did it in that column. I put in that formula and then I just copied it all the way down.
So your first one was
4.8417, yeah.
So I did that and then I went to copy it. It doesn't work.
Huh.
What should the formula be?
Well, that's what I was struggling with.
always end at 17?
It should always end.
Because it's trying to pick up 17 Colorado Road, so it goes down to be 1880.
Well, let's actually see what we get here. If we take out that, let's take out the $, get the same value. So copy. They don't like it. So what I'm not sure about is why that worked for me. Oh. If we take that out, excuse me. Still have that. I'm going to copy that. Try that now. See what we get. Nope. So I'm not sure why that worked now, to be honest, because that was the formula that I used. I stopped it at the $, and it should calculate an alternate X for each of these in sequence. And it might be that I also need to, because it really didn't care for
Each
that.
time are we shortening?
Yeah, we're
X
shortening
would
it.
be- I mean, the X and the Y,
Yeah,
so that it would be like for on row 7,
mm-hmm.
it would say equal trend B7 to B17,
Yeah.
and then A7 to A17.
Actually, it should calculate an X for each value, or a new value of X at A3, and then copy it into C.
It should.
It should. Let's try this one more time. I've got yet one more thing I can try. Trend. Okay. So we've got known Ys, and we've got known X's, and let's put in some new Ys, or new X's. Okay. Good enough. All of which have zeros now. What it really ought to be doing okay, is calculating these, and it's not going to like it. One or more circular references. Okay. Let's try something different. Let's try this. Known Ys, known X's, and we want to put our new X's in here. And then they don't like any of it. I don't know how I managed to make it work. But we see here, it says, okay, what I'm going to do is just erase all of that and try again. Okay, so that erased all those points. So if we go up here and try trend, known Ys, known X's, we get a value, and then let's copy this into these others and see if it works. No, they don't like it. Sets everything on the 0 line. Interesting. So let's do up here again. And this is what I had done the first time. I plugged in that as a fixed endpoint. The beginning endpoint would be 3, 4, 5, etc. So it'll give me the same value. Now if I copy this and plug it in, it doesn't want to give me that. I don't know what I did to make that work before. This does not make sense. I've got one value. This should have been escape. Try one more thing. Thought I'd solved it the other day. Yeah, it gives me the same value, so that's no good. But if I go B, if I go A4, to A17, what is that going to give me? Nope, doesn't like it. Oh. B4 to B17. Nope. You know, I don't have any idea how I got that to work. That's kind of embarrassing. That's kind of, not only that, it's kind of annoying. Because it ought to go down.
But if you were to manually go in and enter 17, B17, A17, and enter everything, is that what we're looking for, or am I?
No, I just tried that. And it didn't work. Okay.
No, I mean on each formula.
Okay, here's how I did it.
Okay.
I fixed the endpoint on both of them at 17. So in this one, we've got 4. In this one, we've got 5, etc. See that? So it starts to get a little wonky here where we have two values of 25 or two x's of 24 with different values. 19 and 25. So the when you have that kind of thing, it confuses it. But if you take a look at the beginning of that, this is a straight line. And we can project that on up as to what it should be. And in fact, we've got what? 237s as well, with very different values of y. And the last 2 points are kind of funky.
Yeah, 45.
Yeah. But there's really, so let's go back and look at trend and see if we can get any help on this function. If it's a straight line using the least squares method of known y's and x's, returns the y values along that line for the array of new x's that you specify. Okay? Doesn't really give us okay, so we do have to input the formula. Really doesn't explain this very well. But anyway, that's how I got it to give me any results whatsoever. And as I say, the last few points are kind of funky. And it gets confused when you have two x values with different y values and very different y values. If you look at x equals 29, we've got 4 and 42. So it's returning 31 and 46. So basically that is a range of almost 32. Yeah. So basically that's about a 49. Close to 50. Yeah. Oh, no. 31 and 46, that's a difference of 14, so 38 roughly. So, I mean, so it's confused. It actually confused things with two different x's with, or the same x with two different y's. We're talking about 29, x equal 29. We've got a couple here. We got x equal 24 with two different values, 19 and 25. And we've got x equals 29 with 4 and 42, and x equal 37 with 40 and 67. So we have very confused data, and the trend analysis can't deal with that. We can see, however, that where we have one x and one y, we have a straight line. It just becomes a little more complicated, a little funkier, as I said, when we are trying to match that. Let's do a quick check. Nope, no word from Candy. All right. So, aha. All right.
How are you?
Better.
Rough night. How's he doing?
Doing okay. Did not want to sleep last night.
Well, that's That happens. So M&M's.
Yeah.
See anything in there, I can't live without that. I think I'll just live without.
All right.
Thank you.
You're welcome.
Thank you, Cody.
Have a good hour.
Thank you. Yeah. Yeah, I'm gonna let you know so you will pop. So, anyway, we can at least get some of this. And so, as I said, I guess when I played with this, it's when I fixed the endpoints, because unfortunately, what happens if you don't fix the endpoints and leave the beginning points to float, then what it's doing is when it goes down to B4, or goes down to one more down, it's going to go then B4 to B18, which is no data. So that's where I see the problem coming in. So we fix the end, but the problem is then the number of data points that we're using to define our line limits. This is why, using intercept and slope gives us a more accurate picture. But anyway, and we figured the slope was 1.15, which is going to be about a 15-degree slope, which is, let's see, looks a little higher than that. It looks more like a 30% slope to me. But nonetheless, if we do that, and part of it is this scatter, part of it is the nature of this data. When we have vastly different values of y for the same value of x, it confuses the analysis. So if I were doing this, I might experiment with my database and say, okay, 24 was 19 and 25. So we have x equal 24 twice, 19 and 25. That's 6. So if we average that at 22, how would that change the look? When we get down to 29, we got 4 and 42. Well, that is now a 46. So we'd be looking at making our x value 23 if we averaged them. So when and it's one thing to average numbers that are fairly close together. It's another thing to average them that are very far apart. It makes me wonder about how we got this data. Okay, and then we go down to 37. There's a difference here of 27 between them. So 40 and 67 is 107. We'd average that at 53.5. And by golly, that's what they've got for the first one. Now the last two don't change because there's no trend. In fact, it goes the other way. The higher x, the lower y. So it's like those data are complete outliers. And in fact, 67 pretty much is an outlier. So, we've got x in order and y are just values. So we've got a couple of them. And, you know, some of these things are kind of weird. We go from x equal 15 with a y of 10 to x equals 16 with a y of 6. So that's going to influence our calculation. So I think that one of the limitations here is, what do we do with data that that don't quite match up? And what we're looking at, the more important issue from my standpoint is the correlation coefficient. And the correlation coefficient is going to be a better idea as to all we're, you know, quite clearly the general trend is the higher X, the higher Y, but we have a couple of points that just don't match up, such as this one at the two that we have at 29 that are so vastly different. So we have to look, you know, we can put all this in, but we have to be careful how we do the analysis. As I say, as far as I'm concerned, calculating the intercept and the slope is probably a more accurate. And then drawing the line, and then you can calculate the x-intercept, which we did. And you've got your 2 points, you can simply draw your straight line. So it really is a little, you know, this is this kind of correlation analysis. I'm kind of annoyed at the question being asked and the data points you're being given, making it hard to do. Let's go back to the assignment, because here we're going to line of best fit. So we calculate the linear correlation coefficient and describe what that information provides. It tells us merely that these things follow the same pattern. You know, generally speaking, they're on the rise. Okay. So generally speaking, the higher the X value, the higher the Y value, with some major exceptions. I would be looking at that and I would say, okay, we've got a couple of points that don't seem to work. And I would question the data that gave us two different values of Y for the same X. And we've got 3 examples of that in this one data set. So that's going to affect the line of best fit. So we use the trend, and you know, so this would make us look to see 2 things to me. It would make me re-examine the data. Do we have any reason to believe that any of this data is incorrect? It would lead me to then question, you know, how whether we needed more data. You know, again, we've got these very disparate results for values of X. So what happens if we test again for another value of X? And these obviously are just data, and it's not clear to me what the purpose is. But in terms of your job, what you're doing is looking at you might be looking at the seasonality of sales. We all know that this time of year is when most retail outfits make the most of their profit for retail operations that have a seasonal component. Grocery stores don't fall into that. Yeah, you're going to sell a lot more turkeys this time of year. Yeah, you're going to sell a lot more hams at Easter. So what? I mean, that's something, again, that's another complicated, but you're going to be selling milk and potatoes and sugar pretty much steadily throughout the year. So, and you will looking at clothing, we sell clothing throughout the year. The only question is, when do you sell winter clothing? That's why they stock it in August and September. You walk into a store and there's winter clothing in August, and you think, I don't need it now, but that's when people buy in preparation for the winter. Now, wintertime in Florida is different. You know, they might start selling longer pants in August, right? But and then it was really weird. My wife, as a physical therapist, used to have patients who were having lots of muscular spasms. She would recommend that they get a vibrator. And they make lots of different kinds of vibrators just to basically give a vibrational massage to those muscles that are doing that, and especially with people who are bedridden and don't get out much. Sometimes they get lots and lots of things like leg cramps and stuff. So she would recommend they get that. So and occasionally, if somebody were housebound, she would say, well, I'll go out and get one for you and you can just pay me back. So she charged off to Walmart one day and got there and was looking for a vibrator, and they said, oh, that's a seasonal product. And she said, would you repeat that, please? Why is that seasonal? But it's how they define it. It's something they only carry certain times.
Jewelry boxes. Those are around at Christmas.
Yeah,
I'm like, okay.
yeah.
Probably back then.
Yeah, and there's other things
Like you
that
normally wouldn't think.
that you wouldn't think were seasonal, but they are defined as such. Some things, yeah, there's a seasonality to snow gloves and snow boots and snow shovels. Yeah, but there is no seasonality to socks and underwear, right? There's no seasonality to baby clothes. Because us humans, we reproduce year round.
And my niece tore her swimming suit, and it was August. So we went to go buy her one. They only had winter clothes out. We were like,
Yeah, yeah. You'd think
at
that
least
there'd be,
overlap.
yeah, there'd be at least some on the shelf left over, but no. Again, this is where the financial controls in these places come in and say, we don't sell enough of those in August, so we're not going to stock them at all, instead of just having a few leftovers. Or if you go in and you find ones that are either, the ultra small or the, 10x large, and that's all that's left. And so you either you find nothing that works. So we've had that problem before. You go in and all you can find is the stuff that doesn't fit but 1% of the population. And most of us are not in that 1%.
Yeah. Well, and another thing that gets me is when I go look for shoes, 6.5, almost always out. But there's plenty of all the other things. I'm like, Why don't they understand we're more 6.5 instead of the same amount of 9.5? Because they have extra 9.5.
Yeah.
And they're out of 6.5.
Yeah, well, again, somebody's gone through and said, what's the distribution of shoe size? And then when you find your 6.5, it's about this wide, or maybe this narrow. And yeah, we go through that. My wife has a very narrow 9, and it's very hard to find shoes that fit her any time of the year. So if we find anything that fits, she buys it. But anyway, so going back, at this point, is there anything you particularly want to discuss?
On the assignment with this Excel, did we just say see Excel, or did you want us to write it out? See how you want it?
Just write it out. Yeah, it won't take you much time to do that, and then it'll tell me, how well you actually understand it. So, the only Excel part, I mean, you might end up doing some work in Excel just because you want to do the calculations, but in terms of number 2, it'd just be better to write it out. Okay.
Do you want to see the Excel?
That'd be fine. Yes, I would like to see that. I'd like to see, and the Excel can be, kind of messy, like the one that I have there that's kind of messy. That's okay. I don't mind it.
And I was looking over it, and number 2 is the only one that works with that.
Yep, it is. That's it. Everything else is done differently. Okay. So, anything else? All right, I'm going to pause the recording again. The question was describe, there was discussed this question 1 on the week 3 assignment, describe what types of data analysis would use linear correlation coefficients and line of best fit and the benefits of comparing to a line of best fit. There are going to be in any situation something that will have a relationship between 2 things, and so what we do is then we look at the scatter plot, just the dot plot of the data. And we've seen the scatter plot. It can be sort of showing as in the accompanying spreadsheet with this assignment. Shows that if you look at it, you can see sort of like, even though there's some funky numbers, it looks like in general, as you go across from left to right on the x-axis, the data are going up. So we're seeing that as X increases, Y increases. So we're seeing that as what looks like a trend. Is it real? We do this with correlation coefficient to see if that correlation coefficient is such that it would indicate that, yes, these 2 seem to be moving together. If they weren't, you'd have something that looked, as I said in class the other day, like you sneezed at the data sheet, right? It would just be this scattering of points all over the place, and there would be no obvious correlation. It would have a very low correlation. So what you're trying to do then is answer this following question: if these things are behaving in the same way, is one causing the other? Now, we have no idea in this assignment what X and Y are. We're just given the data points. But if we go back and to the what I was talking about on Monday, to the example of slices, the cost of slices of pizza in New York, along with looking at the cost of subway fare, if we look at the information, we see that they both increase. As the price of pizza goes up, the subway fare goes up, or as the price of subway fare goes up, the cost of pizza goes up. Clearly you'd look at that and say, well, pizza prices are not going to cause Subway prices to go up. So we look for why this is happening to both of them. In the case of the pizza and Subway fare, obviously it's inflation. But it's not so obvious, say, in looking at data in maybe a clinical trial, because we collect huge volumes of data. We look at headaches, we look at what we call side effects, and all drugs have side effects. So what we're doing is looking and seeing side effects. We compare and we look at the data. And if we've done our clinical trial right, we've got really two sets of data. We've got data that once we break the codes, we've got data on patients receiving active drug and data on patients receiving placebos. Okay, so we can look at the trend for the appearance of side effects of varying types based on the amount of drug being given. Logic would say to us that if there are going to be side effects, the more drug we give, the more side effects we should see. Do we see it? So we correlate those two. And if we see what we think we see, which is more side effects being seen the more drug we give, then let's take a look at our placebo data. People not receiving drug. Do we get the same side effects? And as we go through the trials, are we seeing those side effects increasing or decreasing? Well, with placebo, logic would say we shouldn't. And the major side effects and adverse reactions should not be seen with placebo, not to the extent that we see it with active drug, because everybody's biology different. We may have somebody who actually has a liver problem develop while they're taking placebo. So how does that correlate? So what we're doing then is using those two pieces of data, those correlation data, to say, okay, we see this range of same level of side effect with placebo as we see with the drug, so it's probably not related. The drug is probably not causing them. Okay, so there's one example. We might look at looking at from a business side. We might be working for a manufacturing company, and our job might be to to look at trends in the cost of raw material for our manufacturing. Raw materials can have lots of different things that'll affect their price. If we're talking about just, things like petroleum as a raw material, how does that fluctuate? Where are the trends? Are it going up? Does it go down? What do we expect to see when the price of oil at the pump head drops? What do we expect to see for our raw material that's related to that oil? Right? We expect it to see it drop. So we look at that, and our supplier is still keeping the price up. So we say, okay, we understand that price of the drop in the price of raw material isn't going to be immediately reflected in the price of your materials, because the other stuff, earlier stuff, came from a higher price. So, but you'd expect that over time, those costs should drop. And you can go back to your supplier and say, okay, I see where your raw material costs have gone down, but our cost of materials hasn't gone up. I think we need to talk about this. or you can go back and talk to your executives and say, you know, this is what's happening. We should be able to get, you know, to talk to these people, right? So there are lots of places that you might use this, but you're constantly saying to yourself, are they related? Is it just accidental? You know, we expect inflation, okay? So if we're looking at material that buying intermediate materials, if we're in a manufacturing, we might buy partially finished goods and finish them out. Okay, so we expect our partially finished goods to be affected by inflation, but we also want to be looking at other factors. Again, what is their cost of raw material? What is their cost of labor? Have they just been through a big labor strike and had to pay higher wages to their employees? A whole host of different things, you know, and other factors. We look at insurance people are good at this, you know, looking at how they're going to have to pay out based on, you know, you can bet the insurance companies right now are looking very carefully at climate change because it's going to affect in some areas and in every area to a different extent and a different type their payouts. You know, we're seeing much nastier weather patterns. You know, we've seen over the years, we've been watching the incidence of tornado damage has just really skyrocketed. We're having many more F5 storms than we used to. And they're going through and destroying whole cities sometimes, whole towns. I mean, Windsor had a mile-wide tornado go through it a few years ago. So you can bet that the insurance companies are looking at what their likely trend for paying out, you know, claims is going to be based on this change and what that does to weather-related claims. Farmers have to think about, okay, you know, what's going on? What's happened with when we get into a stupid trade war with China and farmers are selling maybe 25% of the soybeans they used to be able to sell. You know, these are things that really make people think. And there's a lot of this that goes on. I mean, if you were working for some sort of analytical think tank that was looking at trends in agriculture, you'd be looking and saying, okay, well, this was something that got thrown at us out of the blue, but we're already worried about climate change. We're worried about, you know, the rise of the decline of the small farm and the rise of agribusiness mega farms. So, you know, these are the kinds of things that you might be looking at. If you were, you know, looking broadly, but narrowly, if you're working in a business, you're going to say, okay, where are sales going? I mean, look at Kohl's has just gone through a reorganization. It's not working. I was reading about that the other day. They have really tried to reorganize. What's happening is retail is getting beaten to pieces by online retailers, not just Amazon. But I mean, when you go right into it, how many catalogs do you get in the mailbox every day? Right? And they all want you to order online. It used to be you could go to the stores that produce the catalogs.
Well,
You don't
stores
have to
kinda do
anymore.
it to themselves, because we were looking for some work pants for my husband. They're like, you know, their website says, yes, they carry them in stores. We go to the store and it says online only. So they dug their own grave.
Yeah. Yeah. Well, I mean, they are. You know, again, there's a management issue. I mean, if you're going to say that it's available in stores, it needs to be in the stores. Because but it's a conversion to a model that obviously has some financial advantages to the business. Stores, you're online, you've got a warehouse and you have a few people that you pay a pitiful salary to run the warehouse. Whereas you've got stores, you've got clerks and stuff that you pay the pitiful salaries to. You've got store managers that are being clobbered all the time. But nonetheless, you've got this hierarchy of people. You have inventory that you have to have locally as opposed to at the warehouse. I mean, we know that if you have these giant warehouses, the cost of maintaining inventory is lower.
Versus all the overhead.
Yeah, versus all, and you've got one set of overheads as opposed to the others. And it hasn't, so we're looking at very much changes, and the people that can adapt to change are going to. Those that can't adapt to change are going to fail. And that's been what's happened. That's why, and the changes aren't necessarily helping anybody at all. I mean, I don't like online. I want to look at something that I'm going to buy. Yeah, I'm gonna want to do that. I mean, recently, my wife and I are looking at doing some more traveling to visit our kids, and we've decided that hauling these two-wheeled suitcases through the airport isn't very easy anymore. So we've been looking at the four-wheel, full rotation suitcases that you can just sort of drag and roll, and they actually roll much easier.
There's also suitcases.
Pardon?
There's also a suitcase where you hold like the little fob in your pocket and it follows you.
Yeah.
Although I don't know how well that would work in such huge, like at Christmas time when there's like hundreds of thousands of people
Yep.
in one little area.
I would not. And I would look at that and I think, okay, it's got to have a motor in it. That's going to be heavy. Right. So yeah, that's interesting. I hadn't run into those. But I mean, we decided to do that. So, we're Costco members. So we went online to Costco. What do you have? And they have their online catalog. And so looked it up and it said, price may be cheaper in store. So we said, okay, well, we're heading to Costco tomorrow. Let's go take. So we get over there and we find it. And the nice thing is we could pick it up. I mean, it's one thing to say it weighs X, but okay, some people are real good with that. It only weighs 4 pounds. Oh, that's real light, or it only weighs 6 pounds. Okay, that weighs 6 pounds. What's the difference between 4 and 6? Well, until you actually heft those things, that's a meaningless difference to me. I mean, if I were a weightlifter, maybe I'd be better off at judging that, but I can't. So we go there and we pick it up, we look at it, how well is it constructed, blah, 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 and we bought from the store, which is what they wanted us to. It's the store wants us to, but we didn't have to. I do a lot of ordering through Costco because I send supplies to my dad's apartment for his caretaker to take care of him. Because she can't get out, and because I can do that, and my brother-in-law and sister don't have to drive an hour and a half across the Washington, D.C. area to take things after they go buy it. So, there are plenty of reasons for doing that, but, it's a case of when you are looking at that and looking at the whole thing, there's somebody has done that analysis. And this, again, statistics. What is our profit margin going to be? And it's not, and can we charge more for convenience? So they do a little bit of work. If you didn't have to go, if we could drop it at your door, would that be preferable than driving across town to a store where they may or may not have it? But again, I would rather go
figure it out. And then if it seems appropriate, mostly I'll go ahead and buy because, you know, yeah, you're buying from the people, but you're also helping somebody else maintain a job.
Right.
You know, so there's a lot of other things that go into that. But but looking at these trends and saying, okay, can we correlate clearly candy sales with holidays? Well, of course, that's a silly one. Yes, of course you can. I mean, when you look at the you know, mega bags of candy they have on the shelf starting at the 1st of September every year for Halloween, got that. Then you've got Easter baskets at Easter, you know, just all these different things. So we can correlate a lot of that. Some of it's pretty intuitive, but others of it isn't necessarily. Um, you know, every business needs to be looking at its sales profile on basically a seasonal and non-seasonal basis. And what you're doing is correlating the sales. I mean, as I say, some things are pretty obvious. Clearly, this time of year, we're going to sell a heck of a lot more eggnog in the grocery stores than we are in July.
Find it.
Pardon?
You can find it.
The reason,
Like the
because,
summer foods or the winter cuts.
yeah, exactly, because they know that they're not going to sell enough of it to be worthwhile. We were in Costco the other day and I saw eggnog liqueur. It used to be you could buy eggnog and mix your own, because I sort of like an eggnog now and again, but I don't drink alcohol. You know, the eggnog in Costco, it's spiked already. How lazy is that? But nonetheless, that wouldn't sell any other time. It's the first time I've seen it. Yeah, yeah. When I drank eggnog with liquor in it, I made my own.
No, even we don't drink liquor and we make them. Well, because lately there's a lot of stuff.
Yeah,
Can't find any, just.
right. It's hard to find it if you don't.
I do make my own shine though. I have my own 5-gallon still in the garage.
Yeah, well, I come from a long line of moonshiners. I know what that's about.
Legally, I can do 5 gallons.
Yeah, yeah. Yeah, that used to not be the case, by the way.
Yeah.
I tell you what, when it can be pretty smooth stuff, pretty dangerous stuff.
Well, I've been questioned on it before because I'd make mine 5 gallons. I'd take to our baseball games and, you know, give them out as gifts. So when he said that I was selling it, so I didn't sell this. I'm a stupid.
Yeah.
Just keep drinking, have fun.
Yeah. Yeah, and that, yeah, but because I've run into some pretty good stuff from the North Carolina mountains when we lived in North Carolina. Pretty smooth. You know, some of it, you know, all of 2 or 3 days old. I mean, not exactly aged in oak barrels.
Well, that's more of your like your bourbon and your deep whiskey.
Yeah, this is basically a type of vodka.
Yeah.
Yeah, clear. But anyway, so what we do with this is that we always are looking for what is the cause. And so a lot of times we'll do this and we'll actually do comparisons. We'll plot the data. We'll take a couple of things. We'll have sales curves, and what we might be plotting on the other side is the cost of our cost of goods. We look at profits. We know that the difference between, you know, sales price and cost of goods is gross profit, right? Because that's, you know, and we may or may not include in our cost of goods, cost of labor, the variables and stuff. But we do have a good idea of what gross profit is. Are they being influenced by other things? And basically, we're looking at why things are changing in our business. And sometimes we're trying to correlate things that don't make any sense and they look like they do. But the problem is people really have a great difficulty understanding the difference between correlation and causation. Causation is a direct, this is what is causing it. Obviously, again, to go back to New York, subway fares do not cause pizza prices to rise. So what is the issue? Inflation, if you plot it on inflation, you're going to get, some data there, but that's when you do the correlation. And so when that correlation becomes very, very close, then you have a suspicion that there's potentially causation, but doesn't have to be. You need to be able to look at factors that could be doing it. And this is a difficulty sometimes, because you might look and say, well, I mean, these things they must be related. Well, they might not be directly related, indirectly through another factor. Okay. Obviously, they're correlated. Okay. And think about that. Correlated is really co-related. They happen at the same time. We know from data, lots of data, that lowering the speed limit will reduce accidents and therefore fatalities, injuries and fatalities on the highways. Okay, is that directly related? Why? So we have to ask ourselves, why does that work? I mean, we lower the speed and it sounds like it works. There is a reason and it does, but we have to go back and say, okay, why does it work? What's going on? Well, you have more time to react. More time to evade, because about 35% of all accidents, there is no sign that either party did a thing to avoid it. Okay? Some of that's because there's no time. You're driving 75 miles an hour, somebody does something, there's no time to react. You cannot have a chance to avoid. But if you're doing things much more slowly, and of course lowering the speed limits never worked. I mean, people just ignored it. And I'm as bad as anybody else. One night I drove across the state of Tennessee from west to east in 4 hours flat. Yeah. I was driving a huge road tank that 100 miles an hour was, no big deal. So anyway, but speed, yeah, but there are lots of places where this can be done.
Like, I've heard of, not numbers precisely, statistics, but in factories where they increase the light, production went up. And when they decreased the light, production went up for a little while.
Right.
Because it was a change for a moment, and then
They were paying closer attention. Yeah. And then they got used to it, and then production went down. Accidents probably went up.
especially with the lights down.
With the lights down, yes. Yeah, I believe that. Yeah. Yeah. There are lots of places where this is done sort of on the fly. I mean, you look at this, yeah, accidents went up. Okay. Give me a number. Well, I don't need a number. We went from having, one guy a day go to the infirmary to 4. Oops.
Yeah.
That's definitely, you don't need a lot of statistical analysis to say there's a relationship here. However, when it's more subtle, when it's maybe there's a 1% increase in defective output, that's more subtle. And the idea, this often was used, by the way, as an excuse for repetitive manufacturing tasks, for putting robots in. Because robots don't care how much light there is.
How their health insurance.
Or they don't need the health insurance, they don't go to the infirmary. All you need is an electrician, right? To make sure they're running.
That's a big thing with the state right now is the employees are threatening strike because we got a 2.3 cost of living increase that the first 5 years that we've had. And then they raised our insurance 20%. So
The left hand giveth, the right hand taketh away.
so people are getting lawyers and everything. Like there's a big uproar right now in there.
Yeah. And okay, are they directly related, or have there been that much of an increase in the cost of providing that insurance? And there's where the statistical analysis comes in.
And their analysis, what they said was because Wyoming insurance is self-funded, that for the amount of money that is pulled in and the amount of illnesses that people have had, that there's such a huge deficit that they had to raise it. So the governor stepped in and said, no, you're not going to raise it 28% because it's more than their raise. So they agreed to raise it 14% for the next 2 years. Yeah. But still, one way or another.
Yeah.
Well, and then there's always the question, okay, 2 years passes, is it going to go away or is it going to stay?
Well, and then it makes me feel bad because he said that, with people who has extended illnesses, well, I'm one of those people. I'm one of those people who have to go see specialists every other week. So, and I'm like, well, sorry guys, I'm making your insurance.
Yeah, well, but that should have been taken into account a long time ago. We know there's going to be a certain level of people who will have these kinds of illnesses. We have those data all over the place, and we can predict that fairly accurately.
They did their first data analysis and they found out that the highway patrol in itself is 17% behind on pay, which, you think, oh my God, 70%, that's a huge amount. Actually, I don't even, on pay, period. So, I don't know how to feel about that because 70% is a lot, but in theory, with how many people there are in Wyoming, 70% is not really too big. Yes.
Yeah, well, yeah, and those, again, what you're doing is putting a perspective on a number.
Right.
And that's part of the problem. It sounds like a big number. You go, wow, we got to do something about that because these guys are out there, the usual lines, risking their lives, which at times that's true, most of the time not. But, there are all sorts of reasons that we have this. So you think, oh, well, we can't let that go. And then you have to look at it from a standpoint of, you have other standpoints to consider. I don't know what the cost of living in Wyoming is.
Almost just the amount of Colorado.
Pardon?
Almost the same amount as Colorado.
I'm not surprised. I mean, there's a certain base that you're going to have to face.
Well, a lot of
Rent is lower though.
not really.
So it's gone up recently.
Because lately, a lot of California investors have come in and buying all these houses and developments, buying all these apartment complexes, and making them California prices with slumlords. I call them slumlords because a two-bedroom apartment and want to charge $1,200 a month for it. You're like, what?
Well, my brother moved out of there about 7 years ago.
Yeah, it was very beneficial. It was cheaper there, cost of living, housing, everything was a lot better there. But now that Colorado's legalized marijuana, they have all the the California,
Yeah.
Oregon, Washington, all these investors coming in trying to buy all this land. And this year, Wyoming just legalized hemp farming. So now all of our land is being bought up by all these Californians, Oregons, Washingtons to try to grow their hemp. So they think that if they come in, they grow their hemp, they're gonna push Wyoming to legalize marijuana, which it is coming. I say it is coming. But it's driving everything up. And like you said, you're talking about mega farming and these little farms is, you know, they are trying to close down these little mom and pop farms that have been there for hundreds of years.
Yeah, we have a,
Well, I just bought New Belgium,
Mm-hmm.
an Australian company.
Yeah.
Who is actually what they said, a Chinese company or a Japanese company. Something like that.
yeah. Well, I mean, that was inevitable, that we go through this in various industries.
Like we were
But-
promised with NAFTA, you know, Trump's gonna come in, he's gonna fix NAFTA. I'm not gonna go political on that, but that NAFTA was supposed to make it where, you know, the Americans were supposed to be able to have their products sold before any imports was in. And it's not going to.
No, and, yeah, there are lots of issues
Well, with
with those
everything
things,
being
but,
so worldwide and
Yeah.
the worldwide, why can't they do it? Nationalism.
well,
What's that called?
well, yeah, well, nationalism is part of it, but the issue is, what we have lost in reality there is that our economy used to be focused at the local level. It's not anymore. And that has led to these mega corporations and CEOs that make hundreds of millions of dollars a year while paying people starvation wages. There are some major, again, you can follow these trends, and you can look at this and you can say, we're headed for some real problems, because when people see that they've got this one class of folks that has everything and they have nothing, that is the cause of revolution. And the end result of revolution is never pleasant. So
Bye.
anyway, so anything else? What else do you need that you,
I'm just kind of working on my test right now.
okay?
So.
Which one? A 3, assessment 3?
my Final.
Oh, the final, okay.
Number that occurs the highest number of times. So the mode, what is the number that occurs the highest times? So like in our final system, mode column sets 2%. So 1, 2 are the ones that there's no answer.
Okay, so Candy, I'm cutting this off now, and I'll get it posted. I hope that you can let me know what's going on. So please get in touch with me.